Hello, students. It's Mr. Terrell, and today I want to teach you about acids and bases. So let's first talk about acids. What is an acid? Well, I'm just going to get right to it. H plus, that's an acid. Now you're thinking, can it be that easy? And as a matter of fact, it is. Let's think of what H plus is, though. It's an ion. You might have pointed that out, a charged particle. So is any ion an acid? The answer is no. It has to be H plus. You might recall that the symbol for hydrogen uh, has an atomic mass of 1, atomic number of 1. So how many neutrons does a typical hydrogen atom have? 1 minus 1 is 0. So a typical hydrogen atom has 0 neutrons. How many protons does a hydrogen atom have? Correct. 1, because the atomic number is 1. So if I have 1 proton here, how many electrons does a typical hydrogen atom have? That's right, 1 electron. Just do a minus sign there. But if it's an H plus ion, then we don't have any electrons, so I'll get rid of that. The only thing that we have left is the proton. So an acid's a proton. Wow. It seems so simple, and it really is. So how does this fall in line with the technical stuff, theories of acids, things like that? Well, here's how it falls in line, guys. Let me increase this a little bit. Falls in line like this. So Arrhenius said that an acid, hopefully I'm spelling this correct, is anything that increases the concentration of, can you guess? H plus, which we know is really protons of H plus. Okay. Bronsted-Lowry said that an acid, hope I'm spelling this correctly, said that an acid is anything that donates a, can you guess? A proton. So that is the technical side. Arrhenius says, well, if you have a chemical and it increases the concentration of H plus in a solution, the amount of H plus in a given volume, then it's an acid. Bronsted-Lowry said, well, if you have a chemical and it donates a proton to another chemical species, then it's an acid. So let's take a look at what that might look like in real life. So let's look at this one, HCl. First of all, what might make you think that this could be an acid? Correct. This H here. What is that going to look like when it hits solution? When it's put in water? Well, is this possible? Yes. Just recall, like when we put a salt in water, NaCl in water, you remember what happened. Without getting all complex about the water and everything, when NaCl hits water, it dissociates into Na plus and Cl minus. So that's nothing new for you to understand. Now, would Arrhenius say that HCl is an acid? Yeah, because it increases the concentration of H plus in a solution. See, there it is. Would Bronsted-Lowry say that HCl is an acid? Well, you might be saying, I'm not seeing it donate a proton to anything. Let's look at that a little bit closer. What actually happens when the HCl meets the water? Let's go ahead and put water in here. HCl is called hydrogen chloride, and it's actually a gas. They bubble it through liquid water. And what happens is HCl, hydrogen chloride, donates a proton to the water. And this interesting little species comes up. What would I be left with? Cl minus. So, yes, Bronsted-Lowry would say that hydrogen chloride is an acid because it donates a proton to water in this reaction. So, don't get too upset about this weird looking ion. We're going to talk about that. This is called the hydronium ion. And it's an important ion to understand. But before we talk about the hydronium ion, just understand that an acid is a proton. In other words, an H plus. And you should be able to see how an H plus, which is this, is a proton. Understand that there's many different species that are able to increase the concentration of H plus in a solution. And many different species are able to donate a proton to something else. Okay, so we're going to find a lot of different examples of that. And actually, while we're at it, why don't we just think of some? How about HNO3? Well, yeah, this could donate an H. Here's another common one, H2SO4. Yeah, we could see that this could donate a hydrogen here. What about, don't let these little subscripts scare you. What about H3PO4? Do you notice something in common with all of these acids? This is nitric acid, this is sulfuric acid, this is phosphoric acid. Right, that they have this H just glaring at us right here, right from the get-go. So that should key you in when you look at a group of chemical compounds, what is possibly an acid. And you'll get acquainted with those as you continue on in your chemistry and physics and bio. You will start to pick up on that. So let's talk about the hydronium ion. So we see that our hydrogen chloride gas was bubbled through liquid water, and we have this solution. Now we have dissolved hydronium ion, I should say aqueous, and we have dissolved Cl minus ion. We don't really care about the Cl minus. You know, the functional part of an acid has all to do with the H plus. So don't get wrapped up in what's coming along for the ride. We don't care about that. Like NO3 minus in this case, we wouldn't care. We would care about the H plus that's around, or SO42 minus floating around. Doesn't matter. Same for PO43 minus, the phosphate floating around if this is dissolved in a solution. That stuff doesn't matter. All right, so let's do a new drawing and let's talk about the hydronium ion and just take away the mystery of that. So if you have a proton and it meets a water molecule in some sort of chemical reaction, I should probably have done that as a double-sided arrow, but let's just move forward. And you get this. I'm going to make it a double-sided arrow. Why not? Okay, there it is. So what that means is water is giving a piggyback ride to a proton. This acts as an acid, and this acts as an acid. Now, you might be saying, well, how's H3O plus an acid? Well, because if H3O plus meets, let's say, something else, some other species, I don't want to get your mind off of what we're really looking at here. Some other species we'll call X. Isn't it quite possible that that piggyback ride of that H plus, that proton is donated to X to form HX? Yeah. So you have to understand when you see H plus or H3O plus, for all intents and purposes, you can really kind of consider them one and the same. Here's a way I like to look at it. Let's say we're counting people that are showing up to a football game. All right, that's important to us. We want to know how many people are coming to the football games. But the people are not walking to the football games, they're taking a car. So let's say the car, let's say the people, each one represents an H plus, but the car represents an H2O. Okay, there's the car. That represents an H2O. So if we're standing at the gate and we know that every car has one passenger, we don't care about the cars when we're at the game. But we do know that for every car, there's an H plus, or there's a person that's coming to the game. So an H3O plus equals an H plus. This is the part that's really being the acidic part, like we said before, that's the acid. The H2O is like the piggyback ride for the H plus. That should help you understand why, for all intents and purposes, we can use these things simultaneously. This stuff confused me a lot when I was learning chemistry back in the day, and I just want to bring this stuff out so you don't get uh, distracted or sidetracked by, well, what's the deal with hydronium ion versus the H plus? But it is worth you remembering hydronium ion. That's important. Okay, so what about bases? So we know about acids. What about bases? Okay, well, here's something cool. All this relates to good old fashioned water. If I put a reaction and I put an H plus here, something plus H plus is going to be equal water, or water will break down into H plus something else. Do you think you can figure out what that missing part will be? Good. OH minus. And that is the partner here. That is the base. I know what you're thinking. Well, really, it's that simple? And the answer is yes. It is that simple. Check it out. Um, let's look at NaOH. You've probably seen that before in your science background. Sodium hydroxide is a base. Well, what would Arrhenius say? Arrhenius would say a base is anything that increases the concentration of what? Could you guess? Increases concentration of OH minus. Exactly. Correct. What would Bronsted-Lowry say? A base is anything that can accept a proton. That's the technical stuff. And as you see, even the technical stuff is very common sense. So if an acid donates a proton, a base must be able to accept a proton. In Arrhenius's mind, if an acid increases the concentration of H plus, then a base must increase the concentration of OH minus. We will call OH minus hydroxide ion. Or you could just say hydroxide for the most part, but it is the hydroxide ion. So let's take a look at some bases. Well, actually, before we do that, let's take a look at sodium hydroxide and how it's behaving. So if sodium hydroxide, simply put, is put in water, and by the way, this is a solid. It's a solid crystal you can find in the chemical cabinet. When we dissolve this in water, what do you think you're going to get? Exactly, Na plus and OH minus. What are some other bases? Well, tell me if you think this is a base or not. What about this? Correct. It's a base. It's a base. And you're going to quickly see that bases are going to be the combination of some sort of metal cation or metal when they're in their compound form and the hydroxide. I put 2 here because we know that magnesium forms a 2 plus ion. And that is acids and bases. If you understand this, you're very well on the way to understand the other aspects that we're going to talk about in future videos. And I hope that this helped you, and I hope you have a great day. Thanks.